Assalamu alaikum everyone. I hope that all you are fine. Okay, our today's topic is regarding the measurement of the high voltage. Previously, we have discussed about the generation of the different types of the high voltage. There was the generation of the power frequency high voltage, high frequency, high voltage, and there was some DC voltage, or you can say there was some impulse voltage as well. So whenever you are dealing about the generation of the high voltage, generation of the high voltage is used in research mainly in the laboratories, for the different industrial testing and the, you can say, in research laboratories as well, because you have to accurately measure the voltage and the currents. And whenever you are dealing with some equipments, the safety is required for the personnel and the equipment as well. So जो मॉनिटरिंग आपके पास डिवाइसेस होते हैं उनको हमने ओवर वोल्टेज से भी प्रोटेक्ट करना होता है, ताकि कोई भी इंड्यूस वोल्टेज जो उधर आ रही है उसकी वजह से कोई इफेक्ट ना हो, which can be due to the stray coupling, and there can be some other factors as well. Therefore, the location and layout of the devices are very important. And second thing is very important, I want to discuss is about the electromagnetic interference. That is, whenever there is some electromagnetic interference, there can be some serious condition regarding the impulse voltage and the current measurement. So it should be avoided, it has to be avoided, and we have to minimize. So with the help of different principles of the measurements, the different types of the devices available, with the help of which we can see the how much high voltage is there in any condition. So we will discuss about the measurement of the high DC current to the voltages, and similarly there will be different high voltage measurement techniques as well. Before going our detail, our topics, they are the different topics we will discuss today. If we classify with the help of the voltages, there are the different types of the voltages. There can be DC types of the voltages. There can be some AC voltage power frequency, and there can be some AC high frequency voltages, impulse voltages, and other, you can say, some rapidly changing voltages as well. इसी तरह अगर हम DC voltages की बात करें तो उसकी high voltage measurement के लिए different techniques हैं. For example, there will be some series resistance microammeter. There can be some resistance potential divider, generating voltmeter, sphere, and the other spark gaps, etc. Similarly, whenever we will discuss about the AC voltage power frequency, there will be some series impedance ammeters. There will be some potential dividers. It can be some resistance type, or it can be some capacitance type. There will be some potential transformers, electrostatic voltmeters, sphere gaps, etc. इसी तरह हाई फ्रीक्वेंसी वोल्टेज इम्पल्स वोल्टेज की बात करें, जो सबसे ज्यादा अहम है और आप भी जानते होंगे, इट इज द पोटेंशियल डिवाइडर. पोटेंशियल डिवाइडर रेजिस्टिव भी हम यूज करते हैं और कैपेसिटिव डिवाइडर भी यूज करते हैं. इसके अलावा पीक वोल्टमीटर भी हम यूज कर सकते हैं या स्फीयर गैप भी यूज कर सकते हैं. So regarding the today's contents, we will discuss about the electrostatic voltmeter principle. What is the construction, what are the limitations of the electrostatic voltmeter, what is the Chubb and the Fortescue method for the HVAC measurement, what is the different generator voltmeter principle, what is the construction, what is the series resistance microammeter for HVDC measurements. इसी तरह जो स्फीयर गैप मेजरमेंट्स HVAC, HVDC और इम्पल्स वोल्टेज में हम कैसे करते हैं, वो कौन से ऐसे डिफरेंट फैक्टर्स हैं जो इस मेजरमेंट में अफेक्ट करते हैं. पोटेंशियल डिवाइडर, जैसे मैंने जिक्र किया, रेजिस्टेंस या कैपेसिटिव होता है. विद द हेल्प ऑफ मिक्स RC पोटेंशियल डिवाइडर्स हम कैसे करते हैं मेजरमेंट. एंड एट द एंड वी विल डिस्कस अबाउट द मेजरमेंट ऑफ द हाई इम्पल्स करंट रोगोस्की कॉइल एंड द मैग्नेटिक. So whenever you have to discuss about the electrostatic voltmeter, so first of all you need to know about the principle of the operation. अच्छा, डिस्कस करने से पहले एक बात मैं बता दूं, अक्सर मैसेज आ रहे होते हैं कि बुक कौन सी फॉलो की जाएगी. तो आपको मैंने शुरू से ही बता दिया हुआ है कि आपकी ये नहीं, क्योंकि आपका ये जो ज़्यादातर टेस्ट है ओपन बुक होंगे, तो इसलिए आपका जो नॉलेज है वो लिमिटेड अप टू बुक नहीं होना चाहिए. फिर भी जो हमारी रेफरेंस बुक्स हैं वो एक हम हाई वोल्टेज इंजीनियरिंग MS नाइडो और हाई वोल्टेज इंजीनियरिंग बाय द ई कफल यूज कर रहे हैं, और ये जो आज के टॉपिक है ये ज़्यादा मैंने ई कफल से डिस्कस की है। इसके अलावा आप इंटरनेट से भी और अपनी ये PPT पावर पॉइंट्स जो है इससे भी आप रख ले सकते। सो प्रिंसिपल ऑफ ऑपरेशन इलेक्ट्रोस्टैटिक वोल्टमीटर का यूज आप जिक्र करें तो यू नो दैट इलेक्ट्रोस्टैटिक वोल्टमीटर कैन आल्सो बी रेफर टू एन इलेक्ट्रोस्टैटिक चार्ज मीटर। इलेक्ट्रोस्टैटिक वोल्टमीटर हम डिफरेंट लार्ज इलेक्ट्रिक पोटेंशियल मेजर करने के लिए यूज करते हैं। इसको हम डायरेक्ट मेथड भी कहते हैं फॉर मेजरिंग द हाई वोल्टेज। और इसका सबसे एडवांटेज क्या है, इट कैन एक्यूरेटली मेजर द सरफेस पोटेंशियल on the materials without making physical contact. So whenever you are in contact with any equipment, you can accurately measure the surface potential on the materials as well. जो इलेक्ट्रोस्टैटिक वोल्टमीटर है ये एक्चुअली क्या करता है, ये अट्रैक्शन फोर्स बिटवीन टू चार्ज पार्टिकल्स को यूटिलाइज करता है फॉर द मेजरमेंट। और जो अट्रैक्शन बिटवीन टू चार्ज सरफेस क्रिएट अ डिफ्लेक्शन ऑफ अ पॉइंटर, जिसको हम बोर्ड्स में कैलिब्रेट कर लेते हैं। आगे कंस्ट्रक्शंस देखते हैं तो आपको ज़्यादा आइडिया क्लियर हो जाएगा कि कैसे ये वर्कआउट करता है। तो मैंने कहा कि ये दो चार्ज पार्टिकल्स की अट्रैक्शन फोर्स को यूटिलाइज करता है फॉर द मेजरमेंट ऑफ द हाई वोल्टेज। इट मींस कि अट्रैक्शन जो फोर्स है इट विल बी प्रोपोर्शनल टू द स्क्वायर ऑफ द अप्लाइड वोल्टेज। So this measurement can be made for the AC, this measurement can be made for the DC voltage as well. So जब भी कोई electrode is one of the electrodes is free to move, the force on the plate can be measured by the controlling it by a spring or balancing it with some counterweight, जैसा कि हम simple voltmeter और ammeter में करते हैं। Electrostatic voltmeter is designed to measure the high potential differences, typically from a few hundreds to many thousand volts. So this is the principle of operation. Electrostatic voltmeter here utilizes the attraction force between two charge surfaces to create a deflection of this pointer, which is calibrated in volts here. So this is the pivoted N is attracted to the fixed sector QQ. The moving sector indicating the voltage by the pointer P and is counterbalanced by a small weight. This is a small. It is for the counterbalancing here, and the damping technique is like air friction damping here. Similarly, attractive force of question should be raised in your mind, that how much there will be some attractive force between the electrodes of a parallel plate condenser. Then it is given by with the help of this formula, that F is equal to half E naught A V over S whole square. Here V is the applied voltage between the plates, C is the capacitance between the plates, A is the area of cross section of the plates, and the S is equal to separation between the plates. और E naught जो है permittivity है, इसमें हम air use कर रहे हैं तो air will be the permittivity here, and WS is the work done in displacing a plate here. इससे आपको जो आइडिया है वो ज़्यादा क्लियर हो जाएगा. You will see that here one is the fixed light source and the other is the parallel plate, and here it is the medium, and due to the force of the attraction this needle will deflect here, and this is known as the here the mirror. And here the fixed light source, and there will be some mirror deflection, and this is the fixed scales, and this is the parallel space, and this is the air or the S suffix is using as a medium between them, and the easy distance between these parallel plates. And your voltage applying here, and due to the attraction of the charge particles, there will be some deflection here. And this is the calibration as we have seen in the board. This is the more laboratory scene that how there is some light force, and due to the deflection here, there will be some deflection of the light source, reflection here as well. Say, so M is here, the mirror light beam arrangement here, and the C, you will see this is the capacitance divider, and this is the dome, and this is the R is known as the balancing weight here. This is the construction of the electrostatic meter. So the electrostatic voltmeters are made with the parallel plate configurations using the God rings to avoid the corona and they maintain some constant potential. An absolute voltmeter is made by balancing the plate with a counterweight and is calibrated in terms of a small weight. They have a small capacitance of a 5 to 50 picofarad and high insulation resistance that is above the 1000 meter. And they are also considered as the devices with the high input impedance. This is the practical construction of the electrostatic voltmeter. If you are, if अगर हम इसकी upper frequency limit की बात करें तो ये about 1 megahertz की हम achieve कर सकते हैं careful अगर बहुत ज़्यादा carefully हम इसको design करें और इसी तरह accuracy की बात करें तो AC voltage measurement is better than the DC voltage measurement. और जैसा कि मैंने पहले जिक्र किया है, it consists of a parallel plane disc type electrodes which are separated by a small distance d. और जो moving electrode है, it was surrounded by some fixed God ring to make the field uniform in the central region. And in order to measure the given voltage with the precision, the disc parameter is to be increased. और जो gap distance है between the electrodes वो कम से कम होना चाहिए. इसी तरह जब मैंने जैसा कि मैंने पहले जिक्र किया कि here we will use some balancing weight which will give the controlling torque. इसी तरह जो electrostatic voltmeters है, they are constructed in an enclosed structure जिसमें एयर भी हो सकती है, SF6 भी हो सकता है, कार्बन डाइऑक्साइड भी हो सकती है और नाइट्रोजन भी हो सकती है. जो गैस प्रेशर है 15 atm तक नॉर्मली होता है और जो वर्किंग स्ट्रेस है इसमें वो नॉर्मली 100 kV per centimeter. इसी तरह there will be some advantages as well as some disadvantages of the electrostatic voltmeter as well. For example, active power loss is negligibly small. In electrostatic voltmeter, there is a low loading effect. Voltage up to 600 kV can be measured. And there are some limitations. For example, if you have to measure lower than 50 volt, then it is not possible. क्योंकि जो force of traction है between the electrodes वो इतनी ज़्यादा small होगी कि वो deflection नहीं हो पाएगा needle का. So for a constant distance, S F is directly proportional to V square, and so the sensitivity is very small. But this can be overcome by varying the gap distance in the appropriate steps. So another method is Chubb and the Fortescue method for the HVAC measurement. These are very simple and the accurate method for the peak measurement of the AC voltage, and it can be defined as the peak voltmeter method. It was first suggested by Chubb and the Fortescue in 1913. इसी तरह अगर इस मेथड की बात की जाए तो इसमें जो पीक वैल्यू है of the instrument is required for the HV instrument. Similarly, the peak value of an AC waveform is more important. And when the AC waveform is not sinusoidal, RMS value of the voltage multiplied by the square root of 2 is not correct. So, a separate peak value instrument is desirable in the high voltage application. This is the diagram for this method. You are seeing that how there is some protective devices in parallel here. These are the diodes and these are the capacitors here. So whenever a capacitor is connected to a sinusoidal voltage source, the charging current is generated and the meter reading is proportional to the value of Vm, and you know that Vm will be equal to 1 over 2 pi Fc. I उसमें क्या हो जाएगा, DC current हो जाएगा which will be read by the meter, and C will be the capacitance of the capacitor here. So this method is known as जब Fortescue method for the peak voltage measurement. This is what I have discussed already. Another technique is generating voltmeter. So we will in our presentation we will see that what is the generating voltmeter, what is the construction of the generating voltmeter, what is the principle of operation, what are the advantages of the generating voltmeter, limitations, and at the end we will see some numerical problem related to it. So first of all, the question is, what is generating voltmeter? A generating voltmeter can be defined as a variable capacitor, electrostatic volt generator, which generate the current proportional to the external voltage. And this device is usually driven by some external synchronous or the constant speed motor, and does not absorb power or energy from the voltage measuring source, or you can say there will be no loading effect. The generator voltmeter similarly can measure the loss-free AC voltage. It can these are in fact the high impedance devices. So you can say there will be no direct connection to the high voltage. This is the construction of the schematic diagram of the generating voltmeter, which employs the rotating vanes for the variance of the capacitor. And this is the synchronous motor connected to the D naught, and the high voltage electrode is connected to a disk electrode that is D3 on the axis of the other low voltage electrodes D0, D1, and D2 here. Here, the rotor D naught is driven at a suitable constant speed by a synchronous motor, and the rotor vanes of D naught cause periodic change in the capacitance between the insulated disc D2 and the high voltage electrode D3. The number and shape of the vanes are designed in such a way that a suitable variation of capacitance is achieved, and the AC current is rectified and is measured using moving coil meters. If the current is small, an amplifier may be used before the current is measured. The generating voltmeters are linear scale instruments and applicable over a wide range of voltages. And their sensitivity can be increased by increasing the area of the pickup electrode and by using the amplifier circuits. इसी तरह प्रिंसिपल ऑफ ऑपरेशन की बात करें तो क्योंकि हम कैपेसिटर यूज कर रहे हैं, so we have charge stored in the capacitor by the equation Q is equal to CV. So if the capacitance of the capacitor varies with time when connected to the source of the voltage, you know that the current through the capacitor will be equal to dq by dt, and we can write that it will be equal to v dc by dt plus c dv by dt. So from the principle of the operation, you can say that for the DC voltages, dV by dt will be equal to 0, and your expression will become I is equal to dq by dt, and it will be equal to v dc by dt. So now if the capacitance varies between the limits C naught and the C naught plus m, you can write that C is equal to C naught plus Cm sin omega t. So current will be given by this equation, and the RMS value of the current will be equal to VCM omega over under root 2. Similarly, principle of operation, if you are talking about the principle of operation for a constant angular frequency, here the current is proportional to the applied voltage as given by the equation, and the generated current is rectified and measured by a moving coil meter. And you can say the generating voltmeter now can be used for AC voltage measurement, also provided the angular frequency is the same or equal to the half that of the supply frequency. So there will be some advantages and disadvantages of the generating voltmeter. For example, there will be no source loading by the meter, so it is the advantage of the generating voltmeter. There is no direct connection to the high voltage electrode. It is the advantage of the generating voltmeters. The scale is linear, and you can say the extension of range is easy, and it is very convenient instrument for the electrostatic devices such as the Van de Graaff generator and the particle accelerators, as we have discussed in our high voltage generation. Similarly, there can be some limitations of the generating voltmeters as well. For example, they will require the calibration, the careful construction is needed, and a cumbersome instrument requiring an auxiliary drive, the disturbance in position, and the mounting of electrodes make the calibration very invalid. For example, let's see with the help of an example. For example, we have a generating voltmeter and we have to design so that it can have a range from 20 to 200 kV in DC. If the indicator meter reads a minimum current of 2 microampere and a maximum current of 25 microampere, what should the capacitance of the generating voltmeter be? तो कैसे करेंगे ये? सबसे पहले तो आपको पता होना चाहिए कि आपने करंट अगर फाइंड आउट करनी है, बट कैपेसिटेंस फाइंड आउट करनी है, तो सबसे पहले आपको करंट का आपके पास फॉर्मूला है जो आपने डिस्कस किया ऑलरेडी, विच इज इक्वल टू IRMS इज इक्वल टू VCM ओवर √2. दिस इज द फॉर्मूला. अज्यूम कर लेते हैं कि सिंक्रोनस स्पीड 1500 RPM है. अब इसमें जो V अप्लाइड वोल्टेज है, जो CM है वो आपके पास क्या है? इट इज द कैपेसिटेंस ऑफ द मीटर और ओमेगा इज द एंगुलर स्पीड ऑफ द ड्राइव. So by putting the values, you will get the value of CM here will be equal to 0.9 picofarad. So from here you can calculate the IRMS, and IRMS will be equal to 20 microampere. So the capacitance of the meter should be 0.9 picofarad, and the meter will indicate 20 kV at a current 2 microampere and 200 kV at a current of 20 microampere. Another method or technique is the series resistance microammeter, and our content of presentation. What is the series resistance microammeter? What is the operation and what are their drawbacks? जैसा कि नाम से पता चल रहा है, series resistance microammeter, a large value of resistance is connected in series with the ammeter, microammeter. और इसके जैसा कि मैंने पहले जिक्र किया, तो पैरेलल में हम एक प्रोटेक्टिव डिवाइस भी यूज कर लेते हैं, जस्ट लाइक दिस. Here your high voltage, this is the resistance, this is the microampere passing, and here we are using in some parallel devices in the parallel, और normally हम zener diode को use कर लेते हैं. तो नीड हमें जरूरत क्यों पड़ी हमें प्रोटेक्टिव डिवाइसेस की? फॉर एग्जांपल अगर हमारी रेजिस्टेंस जो है वो फेल हो जाती है और हैवी करंट फ्लो करने लग जाता है माइक्रो एम्पेयर की जगह, तो हमने एक प्रोटेक्टिव डिवाइस यूज कर लिया ताकि वो डिवर्ट कर दे. तो इसका ऑपरेशन की अगर हम बात करें सीरीज रेजिस्टेंस माइक्रो एमीटर की, तो जाहिर सी बात है जो रेजिस्टेंस है वो ज़्यादा हाई होनी चाहिए ताकि करंट ज़्यादा फ्लो ना करे. हाई डीसी वोल्टेज जो है हमें अप्लाई करनी पड़ेगी, एंड वोल्टेज ड्रॉप, देयर विल बी सम वोल्टेज ड्रॉप अक्रॉस द रेजिस्टेंस, and the current flowing through the resistance it will be in microampere. इसीलिए जो हम ये इसकी रेजिस्टेंस भी बनाते हैं, वी मेड इट विद द हेल्प ऑफ सम लार्ज नंबर ऑफ वायर बाउंड रेजिस्टर्स इन द सीरीज. So here voltage V is equal to IR, drop in ammeter is negligible. Resistance can be chosen from 1 to 10 microampere, and deflection will be of about 500 kV, and the accuracy is approximately equal to 20%. So there are some drawbacks as well. For example, power distribution बहुत ज़्यादा होगी, temperature external effect बहुत ज़्यादा होंगे, there will be some source loading as well. Another very important method is the sphere gap measurement. AC के लिए भी यूज हो सकता है, DC के लिए भी यूज हो सकता है, और हम इसे impulse के लिए भी यूज कर सकते हैं. अगर importance की बात की जाए तो जो peak value of the voltage causes the breakdown, so we can utilize the sphere gap here, which can be used for the measurement of the peak value of the voltage if the gap distance is known. I'm again repeating, a sphere gap can be used for the measurement of peak value of the voltage if the gap distance is known, because you have to calculate the how much voltage is with the help of some gap distance. Sphere gap measurement is one of the standard method of measuring the peak value of the high voltage. It can be DC, it can be AC, and it can be impulse voltage. As we can measure the three types of the high voltage here, that's why the sphere gap method is very important now, and it is also used in the small industries for the measurement of the high voltage. It is used for checking the voltmeters and the other voltage measuring devices which are used in the high voltage testing circuits. And similarly, agar aap there are some two types of the sphere gap arrangement. वो डिपेंड करता है कि आपने कंस्ट्रक्शन कैसे की गई है. It can be some horizontal type and there can be some vertical sphere gap arrangement है. अभी आगे आके प्रैक्टिकल इसकी शेप भी आपको दिखाता हूँ. अगर स्टैंडर्ड डायमीटर ऑफ स्फीयर्स की बात करें, अभी तक आपको पता तो लग गया होगा, अंदाजा हो गया होगा स्फीयर गैप की बात हो रही है. इट मींस देयर विल बी सम टू डिफरेंट टाइप्स ऑफ द स्फीयर ऑफ डिफरेंट डायमीटर्स, और जब वो हम क्लोज करेंगे तो आर्किंग या स्पार्किंग जिधर होगी उधर हम डिस्टेंस से कैलकुलेट कर लें. डिस्टेंस से हमें अंदाजा हो जाएगा कि आपकी जो वोल्टेज है वो कितनी है. Standard diameter of spheres, it can be 2, 5, 6.25, 10, 12.5 and so on. जैसा कि मैंने पहले कहा, horizontal arrangement भी हो सकती है और vertical arrangement भी हो सकती है. तो normally हम horizontal arrangement prefer करते हैं for sphere diameter, which is D is less than 50 centimeter and is suitable for the low voltage range. One of the sphere is static and the other is movable, adjustable. Okay, हमने गैप डिस्टेंस को कम या ज्यादा करके देखना है कि हमारे जो वोल्टेज है हाई वोल्टेज वो कितने हैं. Impulse voltage which has the wavefront time at least 1 microsecond and wave tail time of 5 microsecond can be measured using the sphere gap measurement. So this is the construction. You are seeing that one is the movable sphere and one is the fixed sphere, and this is the distance S. And one here, it is the insulating spore. It is the high voltage connection with some series resistor, and A point is the height of sparking point P above the ground plane, and B is the radius of free space from the external. So function of series resistance here, you have to limit the breakdown current and you have to suppress the unwanted oscillations here. With the help of this, you can accurately see what is the horizontal arrangement of the sphere gap. जैसा कि मैंने पहले कहा, horizontal ये जो sphere gaps हैं ये movable. जब ये हम क्रॉस करेंगे और जिस पॉइंट में जाके आर्किंग स्टार्ट होगी उधर से हमें अंदाजा हो जाएगा जब डिस्टेंस को हम वोल्टेज में कन्वर्ट करेंगे कि जो हम मेजर करना चाह रहे हैं वो वोल्टेज कितने हैं. So this is the vertical arrangement of the sphere gap. This is the written D diameter of the sphere should be greater than 2D. Similarly, here it should be greater than 1.5D, and similar the other sports arrangement are written in the vertical arrangement. This is the real practical construction of the sphere gap, with the help of which you can calculate the measurement of the voltage. So whenever the electric field across the gap exceeds, there will be some static breakdown strength of the gap in between, and it will result complete breakdown of the gaseous gap. जो ये spheres हैं, ये they are up usually of equal diameters. ये copper के भी हो सकते हैं, या aluminium के भी हो सकते हैं, and the distance between two spheres are less than the diameter of the spheres. I'm again repeating, the distance between two spheres will be less than the diameter of the spheres. जैसा कि मैंने पहले कहा, जो स्फीयर गैप्स हैं ये वर्टिकली भी अरेंज किए जा सकते हैं, विद द लोअर स्फीयर ग्राउंडेड, और हॉरिजॉन्टली भी किए जा सकते हैं कनेक्टेड टू द सोर्स वोल्टेज horizontally with the one sphere grounded, and these spheres are very carefully designed and fabricated so that their surfaces are smooth and the curvature is uniform. Because अगर इसके स्मूथ सरफेस नहीं होगी तो क्लम्प थ्योरी और बाकी थ्योरी जो इम्प्योरिटीज हैं उससे हम पढ़ चुके हैं कि कैसे इलेक्ट्रॉन ब्रेकडाउन स्टार्ट हो जाए. और जो स्पेसिंग है इन दोनों के दरमियान, फॉर एग्जांपल की एस स्पेसिंग है, इट विल गिव यू द मेजर ऑफ द स्पार्क ओवर वोल्टेज. और जैसा कि मैंने पहले बार बार जिक्र किया, जैसा कि ऊपर भी आप देख रहे हैं कि सीरीज रेजिस्टेंस हम कनेक्ट कर देते हैं बिटवीन द सोर्स एंड द स्फीयर गैप, ताकि जो करंट है उसको लिमिट किया जा सके, ब्रेकडाउन करंट को, और जो अनवांटेड ऑस्किलेशंस हैं इन द सोर्स वोल्टेज उसको भी कम किया जा सके, या इंपल्स वोल्टेज में बहुत ज्यादा होती है. The value of series resistance कितनी यूज की जा सकती है, it may vary from 100 to 1000 kilo ohms, and it will depend कि आप AC वोल्टेज है या कौन सी वोल्टेजेस हैं. For AC और AC voltages not more than 500 ohm in case of impulse. So now there will be the different factors which will affect the measurement. For example, there can be some nearby earthed objects which can change the breakdown strength. There can be some atmospheric conditions and humidity. Breakdown voltage spark gap, you know, that depends upon the density as well. There can be some irradiation problem as well. There can be some polarity and the rise time of the voltage waveforms. You know that breakdown voltage for positive and the negative polarity impulses are different, as we have discussed in the positive and negative during the corona discussion as well. There will be some influence of the dust particles, and you know that the presence of the dust particle can cause the erratic breakdown as well. So the next topic is the potential divider. Potential divider की बात करें तो potential divider क्या है? It can be very useful for the high voltage DC and the AC measurements, and the potential dividers are usually either resistive or the capacitive, and there can be some mixed element type as well. अगर low voltage arm divider की बात करें, it is usually connected to a fast recording oscillograph, or a part reading instrument through a relay cable or the coaxial cable, and it will be somewhat like this. Here you are giving the high voltage, these are the potential divider, and here this is your delay cable, and here this is your CR. Here Z1 जो आपके पास है, it can be a it is usually a resistor or a series of the resistors in case of resistor potential divider, or Z1 is usually a single or a number of capacitors in case of the capacitance divider, and you can say the Z1 can be able to use the combination of resistor and the capacitor in case of a mixed RC potential divider. और अगर Z2 की बात करें, it will be a resistor or a capacitor, or you can say an RC impedance, and it will depend upon the type of the divider कि आप कौन सा type use कर. So a simple resistance potential divider consists of two resistances R1 and R2 in series. And the voltage ratio, जिसको हम attenuation factor भी कह देते हैं, it is given by V1 by V2 will be equal to 1 plus R1 over R2. The divider element R2 in practice is connected through the coaxial cable and to the oscilloscope, as we have seen in this diagram. So this is how the potential dividers work. Here you are giving the high voltage. These are the impedance or potential divider, and it can be mixture of some capacitance as well. And here it is connected to the coaxial cable, and here it is terminated with some such cable oscilloscope के साथ आपने attach कर दिया. So this is the output of the compensated resistance voltage divider for the different degrees of the compensation. जो केबल आप यूज कर रहे हैं, it will generally have a surge impedance as well, वो हम डिस्कस कर लेते हैं, and it is denoted by Z naught. The surge impedance will come in parallel with the oscilloscope input impedance. RM will generally be greater than 1 mega ohm and centimeter, and it can be from 10 to 50 picofarads. और अगर high frequency और impulse voltages की बात करें, so the ratio and the frequency domain will can be calculated with the help of this formula. Similarly, there can be some capacitive potential divider as well, because the harmonic effects can be eliminated with the help of the capacitive potential divider with some electrostatic voltmeter. So here you are using some capacitive potential divider. Here the H high voltage is given. This is the coaxial cable, and here you are connected some electrostatic voltmeters. The gas filled condensers C1 and C2 are shown in the figure. C1 is the three terminal capacitors connected to the C2 by the shielded cable. Here, the capacitive potential divider can measure the fast rising voltage and the pulse and impulse voltage. Similarly, the capacitance ratio is independent of the frequency. The capacitance C1 is found between the high voltage terminal of the source. Or agar hum, it will be somewhere like this. This is the capacitor voltage divider for very high voltage and its equivalent circuit. It is suitable for measuring the impulse voltage up to the 1 megawatt. Now impulse voltage कैसे हम calculate कर सकते हैं with the help of this form. You can calculate the capacitance potential difference as well. So there are some advantages and disadvantages as well. For example, loading on the source is negligible. The capacitance ratio is independent of the frequency. These are the mixed potential dividers which are using RC elements, resistance as well as the capacitance, or they can be in parallel as well. And this is the direct arrangement of the potential divider. So there can be some different errors in the potential dividers due to the residual inductance. It can be due to the stray capacitance between the elements from the sections and the terminal of the elements from the high voltage lead to the elements. Similarly, there can be some impedance errors, connected leads and ground return leads as well. And there can be some parasitic oscillations due to lead and the cable inductance as well. Whenever you are measuring the high voltage, there are the two very important terminologies. One is the surge impedance and the other is the parasitic capacitance. Surge impedance क्या होती है? It is the characteristic impedance, or you can say a surge impedance of a uniform transmission line. And you can say it is the ratio of the amplitude of the voltage and current of a single wave propagating along the line. उसको हम normally V naught से represent करते हैं. That is a wave traveling in one direction in the absence of reflections in the other direction. Our characteristic impedance, surge impedance, can be determined by the geometry and the material of the transmission line. And for a uniform line, it is not dependent on its length, और जो SI unit है characteristic impedance का, it is in the ohm. I am again repeating, it is the ratio of the amplitude of the voltage and the current of a single wave propagating along the line and the wave traveling in one direction in the absence of reflection in the other direction. And it can be determined by the geometry and the material of the transmission line, and for a uniform line, it is not dependent upon the length. Similarly, if you are talking about the parasitic capacitance, like if you are talking about electric circuits, the parasitic capacitance, stray capacitance, और when relevant self capacitance भी हम इसे कह देते हैं. आपने देखा ना, अक्सर हमने लिखा stray capacitor, so there should be some question in your mind that what is stray capacitor. So it is in fact an unavoidable and usually unwanted capacitance that exists between the parts of the electronic component or circuit simply because of their proximity to each other. जितने भी आपके एक्चुअल सर्किट एलिमेंट्स हैं, जैसे कि इंडक्टर्स हैं, डायोड्स हैं, ट्रांजिस्टर्स हैं, they have some internal capacitance which can cause their behavior to depart from that of ideal circuit elements. So additionally, there is always some non-zero capacitance between two conductors, and this can be significant at the high frequency with closely spaced conductors, such as wires or the printed circuit boards, etc. So power system applications may, as well as in other scientific and technical fields, it is often necessary to determine the amplitude and waveform of rapidly varying high currents. High impulse currents occur in lightning discharges, electric arcs, and the post-arc phenomena studied with circuit breakers, and with electric discharge studies in the plasma field. So inshallah, next time we will discuss about the Rogowski coil. कि Rogowski coil क्या होती है और उसको हम measure कैसे करते हैं. थोड़ा introduction आपको दे देता हूँ. A Rogowski coil is named after the Walter Rogowski. Is an electrical device for measuring the AC or the high-speed current pulses. It consists of a helical coil of wire with lead from one end returning to the center to the coil at the same end of the coil, and the whole assembly is then wrapped around the straight conductor whose current is to be measured. Since the voltage that is induced in the coil is proportional to the rate of change of current in the straight conductor, there is no metal iron core. And this is the shape of the Rogowski coil, and it is used to measure the alternating current through a enable and circle to the toroid. So this is how it is connected to an electrical or electronic, and the, you can see that the output of Rogowski coil is usually integrator circuit to provide output signal which will be proportional to the current here. So if a coil is placed surrounding a current carrying conductor, the voltage signal induced in the coil will be given by the V is equal to MDI by dt, where M is the mutual inductance between the coil and the conductor. Current is the I is the current flowing into the conductor, and the coil is wound on a non-magnetic former of toroidal shape and coaxially placed surrounding the current carrying conductor. Now the question is how you have to choose the number of turns on the coil to get the enough signal induced, and you know that the output voltage given by this formula V is equal to 1 over C 0 to 2 Vt, and it will be equal to Mi over Cr. So the Rogowski coil with electronic or active integrator have large bandwidths, frequencies greater than 100 megahertz. The response is affected by the skin effect. Skin effect क्या होता है? You know that जब भी आप AC किसी भी कंडक्टर से पास करती है तो आपकी जो AC फ्लो है वो यूनिफॉर्म फ्लो नहीं होता, बल्कि आपके आउटर सरफेस से करंट ज़्यादा फ्लो करने लग जाती है एज कम्पेयर टू योर कोर ऑफ द कंडक्टर. दिस इज नोन एज द स्किन इफेक्ट. There are some advantages as well as disadvantages of the Rogowski coil. For example, lower construction costs, temperature compensation is simple, have no ORN core, saturated. So disadvantages, you have to maintain the number of integrator circuits here. Magnetic link can be used for the measurement of the peak value of the impulse currents as well. Magnetic links are highly retentively steel tips arranged on a circular wheel or drum. These tips have the property that the remanent magnetism for a current pulse is same as that caused by a DC current of the same value. So these tips will kept at a known distance from the current carrying conductor and parallel to it, and the magnetism that then measured in the laboratory from which the peak value of the current can be estimated. These are useful for the field measurements, mainly for estimating the lightning currents on the transmission lines and the towers. And by using a number of links, the accurate measurement of the peak value, polarity, and the percentage oscillation in the lightning currents can be made. So this is all for the today's lecture. Thank you very much for your patience. Allah.